Friday, March 8th, 7 o'clock in the evening. This will be the last good night of seeing, probably for several days, and this may be the last opportunity before the moon starts to become a factor again. So I'm heading out to the observatory, which I had set up earlier, and the plan for tonight is to find the first NGC study that is in Orion, and then just continue to cycle through anything that's in Orion. It's not quite sky dark yet. There's still some luminosity out to the west. Jupiter is now no more than 40 degrees above the western horizon. I actually think that Orion itself is a little, maybe Betelgeuse is right on the central meridian and is culminating at this time. As you can see, there's plenty of lights around me, fortunately, using a real-time imaging system. The effects on the retina don't really matter because everything's on a screen anyway. And that was one of the reasons for setting up the backyard observatory and then going to a Revolution 2 system to do real-time imaging. And the other reason is I get to share the images with others. To begin with, let's take a quick look at Rigel once again. I do not expect to see its companion, maybe a little bit of a, because we are the night's a little too dark for that now. Basically, in resolving really bright mated double stars, or even looking at the planets, what you want to do is you want to get out just after the sun sets. That gives you probably the best image contrast that you can get. As it gets darker, things tend to be overwhelming a little bit. The atmospherics change. Anyway, so there's our look at Rigel, and its location on the screen looks pretty good. We're going to push it up. Well, we don't want to go in that direction. We want to go in this direction. We're going to go to 128 flood, 42 decibels. We're going to save out our values. And then we are going to go to the very first NGC study I discovered earlier. Now, I tried to use by constellation with the GEMINI II system, but the navigation was very poor. It doesn't give you a drop-down list of galaxies to check, of constellations to check up. So I just gave up on that and searched through the NGC catalog looking for the first example of an NGC, and I think it was NGC 1661 or 1667. We will start there, and we will stick with Orion, the Great Celestial Hunter, until I've got about maybe a half an hour of video captured. Okay, the very first NGC instance I could find at Orion was NGC 1661. It's at right ascension 4 hours, 47 minutes, and 7 seconds. It's just below the celestial equator at -2 degrees, 3 minutes, and 16 seconds. This is a galaxy of magnitude 13.2, 1.4 by 0.9 arc minutes, spiral with a lowercase bc, meaning 2.5 times removed from the lenticular class on the Hubble de Vauquelins morphological chart. Galaxy is pretty distant, 397 million light years, which probably puts it at about the size of, a little larger than the great galaxy M31 in Andromeda. And you can see the galaxy right there, and I may set her up on it before proceeding to the next study, because I have discovered it's better to synchronize to deep sky studies than it is to stars, especially when it has huge glowing disks. As it turned out, the very next instance of an NGC was 1662, is an open cluster in Orion. Its cumulative magnitude is 6.4, 20 arc minutes in size, some 35 stars, and the brightest of which are 8.3 magnitude. And there is our look. And I'll keep skipping through. Another open cluster is the very next study. A quick look at NGC 1663. It's a rather undistinguished open cluster, 30 stars, class IV2, so the stars are various magnitudes and rather spaced out as a 2,300 light years distant. We're at plus 13 degrees. Let's move on. NGC 1670 is a galaxy in Orion, magnitude 12.7, 2.1 by 1, oblately presented lenticular spiral, class O, 205 million light years distant, puts it about 125,000 light years in diameter. We're at minus 2 degrees and 45 minutes. The galaxy is quite present right there. I might go ahead and center up on it before going on to our next study. I might not. NGC 1671, right about there, is another galaxy in Orion, magnitude 12.9, 1.1 by 0.9 arc-minute, football-shaped lenticular spiral, 283 million light years distant. Puts it about 90,000 light years in diameter. NGC 1678 is another galaxy in Orion. Clearly we're outside the bounds of the winter Milky Way. Magnitude 13.2, 1.1 by 0.8 arc-minute, lenticular spiral, 212 million light years distant. We're within about 3 degrees south of the celestial equator. There's our image right there. NGC 1682 is another galaxy in Orion, fainter, magnitude 14. It's not that baby, that's more like 13. Probably this galaxy right there. 0.8 by 0.8 arc-minutes of lenticular spiral, smack face on, 195 million light years distant. We're at minus 3 degrees. Here we have a nice test in a galaxy. I've often said that at 75x on a good clear night you can see 16.5 magnitude galaxies. Well, this isn't 16.5, but it is visible on the screen right there. Magnitude 16, 1 by 0.4 arc-minute spiral with a lowercase a once removed from Z, 176 million light years distant. We're at minus 3 degrees, so obviously we're getting pretty decent views on this night. I do believe we've now entered into sky dark, and wow, 16th magnitude galaxy right near the celestial equator. I'll have to file that one away. Here's NGC 1684, another galaxy in Orion. You can see that it's brighter, magnitude 13, 2.9 by 1.9 arc-minute elliptical, 198 million light years distant, minus 3 degrees. I would say this elliptical is probably somewhere around 125,000 light years in diameter, and it is clearly displaying as near oblate. Another galaxy located above it on the screen, and there could potentially be several others as well. NGC 1685, nicely placed on the screen, is fainter galaxy in Orion, magnitude 14.5, 1.3 by 0.9 arc-minute, spiral with a bar, lowercase a, but also a lenticular, so a 1/2 removed from a lenticular, 202 million light years distant. We're at minus 3 degrees. Quite a few galaxies right around there, near the belt of Orion, but westward. We've headed a bit north on this one. We're at plus 1.5 degrees for NGC 1690, galaxy in Orion. Magnitude 15, 1.1 by 0.4 arc-minutes. Be interesting if there's any visible oblateness to this galaxy. It's an elliptical, 391 million light years distant, but probably about a little larger than our own Milky Way, maybe 110,000 light years in diameter. And as mentioned, we're at plus 1.5 degrees in declination. I do believe the galaxy is one of these nice fuzzies right there. Let's see if, when I press the next button, that we get another one. Yes, 1691. Oh, but this one's further north, so. Here we have NGC 1691, a galaxy in Orion, magnitude 12. So, well, maybe I'm shifted around or something, because things are doubling up. Anyway, magnitude 12, 1.7 by 1.6 arc-minute, spiral with a bar, lenticular but a lowercase a, and it has a ring. We should be able to pick out that ring of a magnitude 12 galaxy because we've seen a magnitude 16 galaxy already. So that ring just should be a faint, hazy arc in the presence of the galaxy. I will give it a couple of moments here to formulate itself, and as it does so, I can see the galaxy getting brighter. As it does so, what I'm looking for now is I know that Orion is replete with reflection and other types of nebulae. It is a spur of one of the spiral arms of the Milky Way, and there's a great deal of young star formation going on. Eventually, within 1,000,000 years, it'll be populated by numerous open clusters of stars, especially with Messier 42 and 43 implicated in it. All right, I do get a sense of a hazy sense of a ring around this bright central nucleus of a galaxy. So you look at it a little bit more and I will pop up the next study for us to visit. Wow, a number of galaxies, but not in Orion. Here's the next one, 1709. Let's head out. NGC 1709 is another galaxy in Orion, and that's where we're going to pretty much be spending the evening. Magnitude 14.2, 0.9 by 0.7 arc minutes, a lenticular spiral, 211 million light years distant. Not a particularly large lenticular, probably about 75,000 light years in diameter. And we've just tilted below the celestial equator. And I'm going to leave it up to you to find this 14.2 magnitude galaxy for yourself. So no fingers poking at the screen. And now we have NGC 1713, a brighter galaxy in Orion. Magnitude 12.7, but fairly small for a 12th magnitude galaxy, 1.4 by 1.2. And understandably, because it's an elliptical located some 201 million light years distant. We're slightly below the celestial equator, and we haven't quite broken right ascension 5 hour yet. We're at 4:58:54. But there's our view. NGC 1717 is another galaxy in Orion. It's also 1719, so we'll skip that. Magnitude 14.5. Fairly edgy on, 1.1 by 0.3 arc minutes, spiral to lowercase a, 185 million light years distant. We're pretty much right up against right ascension hour 5, just shy of it by 25 arc seconds, and some 15 arc minutes south of the celestial equator. We're going to obviously skip over 1719 as our next study, but if you look at that galaxy, you can really tell, despite its magnitude 14.5, that it is kind of edgy on with about a 3.5 to 1 aspect ratio. We should talk a little more about aspect ratio as we progress. Looks like a bit of a loose cluster up there, but we're actually looking at NGC 1729, a galaxy. Magnitude 13, 1.7 by 1.4 arc minutes, thrice removed lenticular Z. It's a spiral class lowercase c, 163 million light years distant. And I mentioned aspect ratio. One of the things I did early on was to compare other galaxies to a Messier 31 Andromeda galaxy, remoted to the same distance and of the same size, to get an idea of what its brightness would be if Andromeda galaxy were to be at that distance in space and of the same size. And I discovered that galaxies range from about 0.8 magnitudes fainter than Messier 31 would be at that same size and distance, to 1.5 plus magnitudes brighter. And in discovering that, I was wondering whether the aspect ratio plays a role. And the last video I put out, which was Mathematica Galactica, about an aspect ratio, pretty much demonstrated to me that it's a wash. There may be a slight amount of difference, but it's not particularly that significant. I'm surprised. This galaxy almost looks like it either has a neighbor or a ring. NGC 1729. NGC 1740 is a 15th magnitude galaxy in Orion, lenticular class, 184 million light years distant, 1.5 by 1.2 arc minutes, so probably about 80 to 90,000 light years in diameter. We're at -3, and we've finally broken the right ascension 5 hour. We're at 5:01:54 seconds, minus 3, 1745. The galaxy is quite present on the screen. We do have a very good night, as good as we had last night for the Mathematica Galactica series featuring average surface brightness in the arcsecond range. Quite a leap in NGC index numbers to get to NGC 1753, but when I pressed the go-to button, it didn't go far, or a few clicks. We're at NGC 1753, another galaxy in Orion, magnitude 15.5, 1.4 by 0.6 arc minutes. It's a lowercase a spiral once removed from lenticular Z, 172 million light years distant, and we are minus 3 and almost a half degrees in declination. One of the things I do want to mention is this whole thing about Z. That was a previous Mathematica Galactica series. Just ate and there's some food fouling. Anyway, in that series it became, we just had a minor flash and a meteor passage. In that series, it's nice because the galaxy is revealing itself to be pretty large right about there that we kept it on. In that series, a long time ago, last year, I said I wanted to look more deeply into the Hubble-Divalculaires classification system. And I did so, and I realized it's just a morphological system, but that there was an inherent evolutionary maturation process that occurred from the far right, which are irregular forming spirals, all the way to the far left, which are huge, massive globular clusters of ellipticals. And so now I have a way of explaining it to myself and others, and I will mention it as we continue along. NGC 1762 is a smallish, magnitude 12.6 galaxy at 1.7 by 1.1 arc minute. It's a spiral with a lowercase c, 208 million light years distant, and it's just above the celestial equator. The Hubble-Divalculaires morphological system of classifying galaxies, as mentioned before, begins at the far right with incipient spirals called irregulars. It goes all the way to the far left with fully developed, mature, globular cluster-esque massive galaxies that could be 100 to 200 to even 300,000 light years across, but most of their cold dark matter has been converted into stars, and all of their stars are long-lived red and orange dwarf stars. So you got these hot, bright blue stars at the far right of the Hubble-Divalculaires, and you got these old, possibly trillions of years living red dwarf stars, which have roughly a 10th to a 20th of the mass of our sun. Whereas those blue giants on the far end of these young galaxies can have masses 10, 20 to even possibly 40 times that of the sun. Boy, that was great. Look how nicely formed that galaxy is on the screen. We will talk more on this topic. Okay, we've already had a multitude of galaxies in Orion. We've had a couple of open clusters, one of which was an obvious cluster and one of which was less so. We've now encountered our first nebula. Plural are nebulae. This is NGC 1788. It's in Orion. It's 5 by 3 arc minutes inside. It's a reflection nebula, 1,300 light years distant. As a reflection nebula, you can see it on the screen here. It's like a spray of faint light. And that light is being reflected reflected from a progenitor star that basically is illuminating it with visible light, and then that visible light is being reflected off the electrons in the orbital clouds of the atoms and heading off into space, and we're seeing it as a nebulosity. Oh, it's getting nicer. You can see the progenitor star, you can see its nebulosity. Very good. Well, any spiral galaxy on the far right is going to have massive quantities of such matter that's cold and it's dark, it hasn't been illuminated yet, but at a certain point turbulences may be set up within those clouds by gravitation or remote starlight, which will cause a perturbation, and then potentially a massive star will form out of what is called a Bach globule. So the matter gets together, it starts to condense, and then as it does so, the gases and cold dark matter heat up, and then as it heats up, there's some more stabilization process, but at some point the nuclear furnace will kick in, and then you get the shock wave of your stellar life. All right, from that reflection nebula we moved on to a galaxy, and it would have been really nice if it had been an irregular, because those are the types of galaxies that are going through the early stages of star formation with the massive blue O and B type stars of masses of 20 to 30 down to about 5 or 6 times that of our own sun. Kicking off stellar evolution, converting cold dark matter to stars, illuminating over time with the stars getting less and less massive but more and more long-lived. NGC 1819, however, is a spiral with a bar of the lenticular class. And the bar suggests to me that it is still undergoing some measure of stellar evolution. Now, I don't know if this is correct or not, but the lenticular class has converted quite a bit of its cold dark matter into stars and is stabilizing. And there's a certain interesting pattern to the luminosity coming out of lenticular galaxies, which I will explain at our convenience as we progress through Orion. Our next galaxy is an example of a galaxy that is kind of in the middle between the irregulars and the lenticular spirals. It's a class spiral lowercase c. NGC 1843 in Orion. Magnitude 13, 2.1 by 1.7 arc minutes, so rather football shaped, 116 million light years distant. And it's at minus 10 and 2/3 in terms of its declination. You can see the galaxy right up there. Now, it's a lowercase c, which means about halfway between the irregulars and the lenticulars. It is going through, but it's also well organized. It'll have spiral arms, etc. So it won't look like some kind of weird massive light and faintness. It'll have structure to it. Maybe the first class, by the way, of lenticulars that have structure. There are also Ds, and the Ds are the last step before you get to your irregulars. But a C has to go through a B and an A to become a lenticular galaxy, and during that process the galaxy will get more and more converted cold dark matter and gases into stars. And there is a nice relationship between the luminosities, as mentioned earlier, in such galaxies in terms of the various bands or wavelengths of light that astronomers typically measure in terms of galactic light. NGC 1875 is another galaxy in Orion, magnitude 13.6, 3-to-1 aspect ratio, 1.5 to 0.5, very large lenticular spiral class O, 402 million light years distant. It's at plus 6 3/4 degrees in declination. We haven't quite got through hour 5. We're at hour 5:21:45. Now, this is a perfect example of the kind of galaxy that has a very regular pattern. I call it the 1, 2, 3, 4 pattern of magnitudinal deltas between the blue, which is like 441 nanometer wavelengths, the visual, which is something like, I think, 554, but don't quote me, the J band, which is the typical area where there's a blend of reflected heat, longer wavelength, and low temperature stars that are of the M-class stars, which have about masses of 10th to 20th of our sun. And so with lenticulars, you see this relationships in deltas. There's usually a 1 magnitude delta between the blue-violet and the yellow-green. There's usually a 2 magnitude delta between the blue-violet and the J band, and there's usually a 4 magnitude delta between the blue-violet and the K band, which is the longest wavelength of light typically measured in terms of galactic luminosity. It's also, I think, probably just a microwave radiation, so it's not really even considered infrared at that point. Anyway, we should be looking for a magnitude 13.6 galaxy on here. And you know what? I'm seeing something there. So most of the galaxies tonight have fallen in this region here as we've gone north and south. And this one is a lenticular, and it may very well have close to a 1, 2, 3, 4 pattern as I just described in terms of the brightness getting fainter as you move to the blue-violet and brighter as you move towards the microwave thermal end of the radiative spectrum. Continuing our discussion, but first noting that we're looking for NGC 1924, another galaxy in Orion. Magnitude 12.5, 1.6 by 1.2 arc minute, spiral with a bar, lowercase bc, which means between a B and a C, which a B is 2 times and a C is 3 times removed from lenticular. This galaxy has a ring. And given the fact it's magnitude 12.5 and we have a lovely sky up there, that ring would be somewhere around 17th magnitude, and I do believe I am seeing it. Of course, it's not completely circumscribing the core of the galaxy, but you can make it out in its brighter regions. Now, this is a BC, or 2.5 times removed from a lenticular. As you get further to right in the Hubble-de-Valculair's morphological scheme, and you've got more cold, dark matter and gases to form stars, you got younger and more massive stars forming. And younger, more massive stars, when they finally really start to burn, put out a lot of blue-violet light. So what you'll see in a delta, which is called the BV index by professional astronomers, I just call it a BV delta, is it gets squeezed. So it starts out at lenticulars about 1 magnitude, and by the time you get to those really remote morphologicals on the far right that are spirals still, not irregulars, and even irregulars, you're going to see it squeezed in half. So from going from being 2.5 times as bright in the visual versus the ultraviolet, it squeezes down to about 1.5 times as bright at 0.5 magnitudes. Anyway, we are getting a very good look at NGC 1924, and thank you for being an SBBC, so I could explain that the light we're seeing is going to be a little brighter in the blue-violet than we would expect from a lenticular Z equals 0 class galaxy. And despite all the streakiness, what you're seeing right here is a perfect example of what I'm referring to as new star-forming region. We finally ended up near the Sword of Orion, progressing to the east. For an image that I've actually recorded this one before. It's NGC 1973, nebula in Orion, magnitude 7, 5.5 arc minutes. It's emissive, not reflective, 1600 light years. Now you remember that I mentioned something about reflective nebula. Reflective nebula basically just their electrons pretty much just bounce away photons, which I call epiphenomena of what are called spatiotemporal moments. So they bounce away the photons, and it's a reflection like a mirror. But this is an emissive type nebula, and that means the gases that you're seeing there are actually having some of their electrons change orbital states. And when an electron changes an orbital state, rather than simply reflecting away a photon, it puts out a different frequency of light than you might expect. And that frequency is based on the type of atom or molecule that is being having its electron cloud disturbed. And that is the key to spectroscopic astronomy, because when you have ionization occurring and you have radiation of a certain very narrow frequency, it gives you the ability to determine whether there is any Doppler effect in terms of the galaxy's motion. Wow, that is a very nice view of NGC 1973. Well, it doesn't appear we've jumped very far. The NGC 1975, a continuation of that Nebula 73 in Orion. Magnitude 7, 10 by 5 arc minute, emissive once again, 1600 light years distant. Once again, what you're seeing there is actual luminosity that is put out when electrons change orbital states. Now, this whole thing about quantum mechanics, I just don't, I get what they're talking about, but they've really made a big mystery of it. Basically, quantum mechanics says that it has to be a certain frequency of light to impact a galaxy's electrons to cause it to change orbital state. And those orbital states are all kind of incremental. They're not just smooth. The electrons will actually leap from one orbit to another, and when they do so, they either absorb or emit an electron. And that's the key to all quantum mechanical understanding from my personally limited point of view. Now, I'm a polymath and an autodidact, which means I like to study stuff on my own because it's like adventuring and learning things. And so that's my limited interpretation, and it may not be one that's shared with the bulk of physicists, cosmologists, or astronomers. And you know, if I'm wrong, and that's fine by me. I'm not all vested in it one way or the other. I don't have a PhD to defend. All right, you know what this is. This is probably the most luminous, emissive, and reflective nebula in sight of the Earth. It's located 1,300 light years distant. It's NGC 1976, but it has another designation. Because it's so bright, I do believe it was actually seen by the Greeks. But it was included in Messier's catalog as entry number 42. It's magnitude 4 and huge. It's 3 times 2 widths of the moon in terms of actually astronomers imaging it. It's an emissive and reflective nebula, 1,300 light years distant, so the same distance as 73 and 75. And you can see its neighbor right here as well. That's Messier 43. I'm sure it'll pop up. But that is a splendid view of what I would consider to be kind of a parabolic or flower-shaped nebulosity with massive quantities of irradiation occurring. And within 1 million years, there will be one beautiful open cluster there with stars of many different magnitudes and masses. So there's our look at the great nebula in Orion. Well, this is NGC 1977. It's a nebula in an open cluster in Orion. Now notice it's also an open cluster. What does that tell you? It tells you that most of the cold dark matter, gases, etc. associated with this part of space has already been converted into stars. The collective magnitude is 7, 20 by 10 arc minutes, so it should just barely fit in this field of view of this screen. If it were properly centered, it looks pretty close. 1,600 light years distant, so a little further away than the Great Nebula of Orion. We're at -4, almost 5 degrees in declination, and I wonder what causes that flash on the screen every once in a while. Although a car just went by, maybe something reflected in on the dew shield. Anyway, that's a nice look at NGC 1977. Here we have another nebula in open cluster, NGC 1980 in Orion. It's bright, magnitude 2.5, so that must include the stars, 14 by 14 arc minutes in size. It's a class 3-3, and I may screw this up, but a class 3, Roman numerals, generally I've been interpreting that as it's got a disparate number of magnitudes of stars, and a 3 means they're fairly well spread out, but I could have that wrong. But look at the screen. Anyway, it's 1,800 light years distant, and we're at almost -6 degrees in terms of declination. Clearly, this is mostly a reflective or an emissive type. What do you think? Well, you should be able to characterize this one. It's got stars peppering the field, it's got a faint nebulosity, it's probably a nebula in open cluster, and since we're in Orion, that's where it'll be. NGC 1981's magnitude 4.2, larger than the others, 25 arc minutes, 20 stars, with the brightest of which is 6.3. Yeah, you can see them there. It's a class 3-2, which means spread out, but magnitudes are a little closer. 1,300 light years distant. Okay, you know, we're getting down to 2 bars on the camera. This is going to be a long video, but it may be the last one for quite a while, so let's push on. Oh, we've seen this baby before. What does it look like? A conch shell. NGC 1982 in Orion is also Messier 43, magnitude 7, 20 by 15 arc minute, a purely emissive type nebula with obviously some closer obscuring dark nebulosity in front of it. It's 1,600 light years distant. We're at -5 and change degrees and over 5.5 light ascension hours. And there is a splendid view framing up against what I call the Dark Eagle Nebula. There's its head and there's its wings. It's coming above your head. Very, very nice. Well, I suspect that bright star we're looking at right there is one of the 3 stars, Alnitak, etc., one of which I have memorized. That's associated with the belt of Orion. However, it's also associated with NGC 1990, a nebula in Orion, very large, 50 by 10 arc minutes, emissive and reflective, 1,300 light years distant. And yes, we're at -1 and changed in terms of our declination, so I'm not sure whether that's Murphak or Alnitak, but there it's got some reflective luminosity around it. Kind of a pretty color, isn't it? It's blue. What does that mean? It's massive, it's young, it's going to live a very brilliant but short life, and it's going to cause lots of other stars to pop out of the basic fabric of the cosmos. All right, I was hoping we'd get to NGC 2000 before we knocked off. We were one shy. NGC 1999 is a nebula in Orion, 2 by 2 arc minutes. It's emissive and reflective, 1,500 light years distant. We're at -6 3/4 degrees in declination. I think you can see some of the nebulosity. I'm going to go ahead and push on because it would be nice to get to this year, wouldn't it? 2024. Here we have somewhere on the screen a planetary nebula. NGC 2022 in Orion is magnitude 11.7, smallish 28 by 27 arc seconds. Central star of magnitude 15.8 should be resolvable. 8,200 light years distant. We're at +9 and change in terms of declination. I can make out where the planetary is located. The luminosity around that planetary is so bright, I don't think we can reveal the star. However, yeah, I'm sure the average surface brightness of this planetary is greater than the stellar magnitude of 15.8. I had seen this through a 6-inch scope at the eyepiece. I had a Maxitov 6-inch decades ago, but you know, I really always wanted to have a 6-inch refractor, and there you go. There's our view of the planetary NGC 2022. We have one more view. We got 2 bars left on the camera. Let's see if we can get to the year of the Lord 2024. Here we see another very bright progenitor star surrounded by nebulosity in Orion. The nebula itself is 10 by 8 arc minutes, so obviously it's spreading out more than that central region. It's an emissive reflective, 1,500 light years distant. We're at -2 and change in terms of declination. We're at right ascension 54138, and our next study will be the year 2024, and I think many of you already know what particular study is going to pop up. Yep. Now, some people call it the Flame Nebula, but it also looks like a maple leaf. So the Canadians do have something to be to point at in the night sky in order to reflect their appreciation for maple trees. This is NGC 2024, a nebula in Orion of the, obviously, look at the color. So is it reflective or is it emissive? It's an emissive nebula. It is going to shine at a specific frequency that is expected. I believe it'll be hydrogen. It's going to be some kind of singly or doublet, some kind of hydrogen gas that's going to have gone through some kind of ionization process. I'd have to look up to get the details on it. I'm not a chemist, but I understand enough about valence electrons and things to make sense of it. We're at -1 and almost 2 degrees in declination. Our right ascension is 54142. So let me just go ahead and give that to you. We are now concluding for this evening with a beautiful view of the Flame Nebula, NGC 2024 in Orion. It's the size, if you could see all of it, we can, of the moon at 30 by 30 arc minutes. It is an emissive type nebula, which means it is being ionized to some degree, and as the electrons move back and forth and bounce around, they basically give off this colored light, which is reddish, 1,500 light years distant. It's at right ascension 5 hour, 41 minutes and 42 seconds, and it's at declination -1 degree, 51 minutes and 24 seconds. You should be able to see it. Probably a 10-inch scope would give a decent view. It is a fairly low average surface brightness study. You should be able to find it with it. Somewhere in this neighborhood, if you cross Alnitak and you go to the opposite side, you would be able to make out the Horsehead Nebula. And I have yet to find a designation for that, although I could put in its declination and right ascension, and the scope would go to it. But I won't have a chance for that, because this beautiful sky is not going to last much longer. We're going to get more rain and snow here in Grant County, eastern Oregon. So I bid you all a carpe noctem.